So I am Justin Wright, and yeah, this is not quite micro front ends according to the definition, but it's how we built a module front end from some legacy projects that scales very well. And so I thought it'd be worth talking about. So that's what we're going to do. So as in my intro, we're all about empowering small businesses at Swipeclock, where we basically have a bunch of different suites, and those use a variety of modules that we recycle depending on what kind of suite and permissions it has. And that's what we're going to talk about. So let's get into it. Of course, I have a little bit of a disclaimer, and that is that this might not be what you're looking for. In every place I've worked at, every development needs are different depending on the situation at hand, and that's okay. So my goal is basically to share insights, lessons learned, and hopefully maybe you walk away with something that you learned. And of course, questions and comments are always welcome. So the first thing that I want to kind of talk about is what we chose and went with compared to what else is out there. So the environment and the requirements. We support, like I said, a handful of different host sites, and they serve as the backbone for displaying various front-end modules. Each host site's main role is to handle navigation to ensure users feel like they're visiting one cohesive website rather than something that's like mystery meat all put together. And to have that happen, we need to have like each host site typically needs to load one or more modules inside an iframe. The goal is to have honestly one iframe per page, but there have been instances where we've had to have several iframes loaded into a single screen. And sometimes we encounter an inception scenario with an iframe nested within an iframe and then within yet another iframe. But to reduce complexity, I really strive to have just one iframe per page. That's what I think makes things workable for the most part. Alongside that, the host site needs to have various core functions. So in addition to navigation that you can see in the diagram where we have the side nav controlling the iframe module, we have other things. This includes authentication, analytics, and communication via the message bus. By centralizing these functions in the host site, each module behaves consistently across the application. So that's fun. And that brings us back over to module development and versioning. So because it's a module front end, we have several large repositories that manage multiple URL entry points, and each entry point represents a page or a module that can be loaded into any of our host sites. These repositories, they primarily use React right now, but we still maintain some legacy modules from Angular to some other legacy code stacks. The ability to use multiple development stacks is really cool, but a double-edged sword. On one hand, developers come in and they enjoy the freedom to choose their tool sets, which it initially feels empowering. On the other hand, this flexibility comes with risks. If developers specializing in a particular stack leave, of course, remaining teams kind of struggle to maintain the code base because they may not be totally familiar with that. And I'm talking about this because, as you can imagine, we've experienced both edges of the sword firsthand. Since we primarily are a React shop now, our legacy Angular projects don't really get the love they deserve. And so the attention they deserve or the upkeep, because most of our Angular developers have sadly moved on. So in short, the emphasis here is for you to be just kind of mindfully aware that if you start adopting different kinds of stacks, it can come back to bite you. So, and with that, we'll go on to versioning drift. So like I said, we're mainly React right now, We started building our modular front end when React was still on version 15, so a while back. And pretty soon into development, React 16 dropped, and with it came hooks. And a lot of our team quickly jumped ship from class components at that point and forgetting about the complicated React lifecycle and just embraced hooks for better or for worse. This was great in many ways. React hooks really made development easier for some of our developers, but also spurred a race through React versions. While today we aim for uniform versioning, at one point we had things on 15, 16, 17, and 18 all running at once. Version drift always happens to some extent, but when the gaps grow too wide, like from 15 to 18, very quickly version drift can kind of crash the modular front-end party, is what I kind of want to define it as. The big party crasher for us was a drastic difference in UI libraries. We had to pause development at that point to kind of sort these conflicts out. And I would say that I'll spare you the drama and say we did kind of overcome these hurdles, but it wasn't easy. For now, we've decided to freeze our dev stacks. We're happy with our current pattern and don't see a strong business need right now to jump from, say, React 18 to 19 or switch from single page applications to, say, server-side rendering. It's just not in our business needs. And we'll talk more about upgrading and everything like that later, but it's something to be aware. It's not always the best path to take, as we've learned. But like I said, you want to make sure that you don't drift too far away in a certain dev stack, because then it just makes it hard. And that's where we probably want to talk about shared resources and communication. Not everything has to be shared, but we did start to share things. And the thing I think I want to emphasize is once our version drift issues were sorted out, we started building the shared resource library way late in our development process. If I could, in hindsight, I think I would start sooner, but what this did allow us to do was a couple of things. This library focused strictly on things we identified as being valuable. Team buy-in was also super important. Since we wanted everyone using the shared resources, the idea being it would help keep version drift to a minimum and also keep things looking similar and being able to test in the same fashion. So our library includes a shared UI library for common components that we kind of picked out after years of development. And so not everything is shared, but just core components are. Various utility methods. And because we're a React shop, we have a lot of context providers that we share. This setup kind of helps each team stay, like I said, consistent in their designs and in how they interact with the host site. So these shareable resources, like I said, only emerged after our module development matured. In some ways, this was a good thing because we could really kind of take a look at what patterns our teams were all doing. But also it probably started a little too late, if I'm being honest, because we required a lot of tech debt too. So that is that. Shared resources are super important. And then just kind of want to touch on our modules for a minute. I call them super modules. We like to think that they have superpowers because they consume API requests from a host site when it's available. But if it is not, they morph into super modules and they kind of take over. These super modules fetch data directly from our .NET backend services all on their own. This lets them handle multiple integrations seamlessly, whether a standalone application or embedded in a third-party platform or in one of our suites. But this superpower comes at a price. Ensuring our modules run correctly in every environment takes an extensive amount of testing. And so that is something to be mindful of. You might even say that the freedom to inject our modules anywhere is our kryptonite because of the maintenance that comes with it. I would say an example of where this becomes a a wrench in the gears, so to speak, is sunsetting legacy modules. This is challenging because we have to track which clients are still using each version and help plan their migrations sometimes to newer modules. Still, this balance of service integration and module autonomy keeps our system pretty flexible. So that's a win. And then the last thing I would touch up on is, of course, what makes it all worth it, because it's not easy to just kind of go from, say, like a monolithic app to modules. But what makes it all worth it is deployment. Independent repositories for the win. I think I've talked about that. Each module gets its own entry point, loaded via an iframe, and this sets it up to be able to be independently deployed and decoupled from everything else. So things pretty much run smoothly, but I would be mistaken if I didn't say that there's also some other key things here that are not just part of development that make the deployment of module front ends worth it. I'm talking about our critical actors. You have to have a really good QA team and DevOps engineers. Without their skills, this whole thing would just fall apart. Our biweekly release cycles before we went to a module framework were nothing like they are now. Right now, they're down to about 1 hour to 2 hours, but previously we would have all-nighters because of certain bugs impacting several different areas of our code base. So if anything, this module front-end undertaking really helped give back a nice work-life balance in the evenings. And that ends section 1. And I'm wondering if there's, I thought I heard a ping or something. Is there any questions or comments? If not, we can move on.
I've got a question. Why do you decide to release twice a week if releases were so eventful?
Bi-week. I'm sorry, I probably misspoke. Bi-weekly. So every 2 weeks we have a release.
Okay.
Yeah.
Gotcha.
Sorry. Yeah, that was a slip up. Yeah, bi-weekly schedule. So that's just what we've always been doing at our company. So, all right. So with that, part 2 is where we'll cover a quick history of micro frontends, and we'll get to explore different strategies for picking an architecture and compare the pros and cons of each. So I thought that kind of sounds fun. So let's get into that. Before micro frontends, it was monoliths, right? The development landscape was dominated by monolith and full stack apps. This eventually gave way to separate front-end and back-end apps, which dominated for a time. And I'm not exactly sure when, but microservices came into play along with like component-based applications. And this architecture is still very popular and meets the needs for many applications. However, for large teams and large applications, another option exists, which is micro frontends. And so let's talk about the strategies. I've already talked about my favorite or biased one, which is iframes, but they come in, while I was writing this, I would say they'd come in 3 flavors, but then right after I finished this presentation, it dawned on me like web components. So I don't really give web components a lot of love in this talk. They're there, but I would say they also kind of fall into the same camp as what I'm going to talk about next, which is external app bootstrapping. External app bootstrapping is what I got the name from a presentation that I saw a while ago, where basically it uses a host application like iframes, of course, to load in a bunch of CS, JS, and I lost my note place, sorry. Yeah, so it loads in a bunch of CS, JS, and other assets from different servers. And the idea is you load them all in to the host site, and it uses like the window object to stitch things together. And it needs also kind of some kind of event bus, just like iframes. So it's like iframes, but a little bit more complex in some aspects because it's just not relying on the iframe. It's an option. The presenter gave a really nice talk. Their team seemed to really love it. We actually considered this kind of architecture when we were planning things, but ultimately stepped away from it just because of the simplicity that iframes gave us. And it was already what our partners and the third-party integrations were asking at the time. So if you'd like to see more on external app bootstrapping, you can actually just write that into YouTube, or if you visit the blog post that I wrote about it, there's a link there. So that brings us to the modern approach, micro-frontend libraries. There is single SPA and there is module federation, I think are the winning two libraries out there. There's a few others, but these are the ones that I want to focus on because I feel like they're the ones that have been battle tested the most. So let's take a closer look at those now. So module federations is dynamic. I like to think of it as the shiny, happy modules, right? Module federations shines at being dynamic and sharing resources. You can mark some modules as part of your build, so they're local, and others as runtime loaded remotes. It even supports nesting, which is really cool. So each build becomes its own like container, and you can consume modules from other containers. Think of it like iframes, but without the messy window post message glue that you need to get those to work together. The other thing that I would say that it does very well is it handles resources very well. So everything is shared, so the bundle sizes can become very small for these containers. And then as well, if you were thinking about just doing one page kind of builds, like what we do, you'd have a shell, and that one basically declares common libraries as shared modules so they aren't duplicated everywhere. And you can have each container become a separate build per page. And they kind of walk you through that pattern in the documentation. The drawbacks that I think about when I've been learning about module federation and reading up on those that have been using it is this. First, it locks you into Webpack. This might be not a deal breaker. I know a lot of companies, they're not always on the latest and the greatest things that come out in the JavaScript world. And so if you're still on Webpack and you like it, then that's not a problem. But if you're looking for being able to use like Vite or Rollup or some other builder, then this might be a deal breaker. The other thing that basically is a drawback is legacy applications, because everything has to run in the same dev stack. So if your legacy app was written in PHP, get ready for a full rewrite. So that might not be doable. And that's where I think single SPA comes in. So single SPA, what it brings to the game is a variety of things. It's currently the most popular micro front-end solution, and for good reasons. It avoids iframes by hosting multiple JavaScript frameworks together. So your micro front-ends work seamlessly without iframes. And it's just kind of a very nice library to start out with. But it's not for the faint of heart. Building a hello world demo or an initial proof of concept, I think, is very doable. You can go onto YouTube and see lots of examples, but the complexity grows quickly. And I think it's because of this reason that if you go to their site, they even offer classes and tutorials to help with integrating and getting it working for you. So the other drawback is because you're putting a bunch of single page applications all on the same page, it's a lot of SPAs. And the problem is you have to know how to bootstrap or hook them up to the single SPA lifecycle. Instead of using just a single like index.html to host all of your sources and everything, you have to also manage your configurations through the root config, and that gets complex. And you can very quickly find yourself having scoping issues with like say fonts and CSS styles. So it's not the most silver bullet is what I'm trying to say, but all of those little nuanced details that you have to kind of consider still might be nothing more than just something that you have to be okay with and accept for a great system if that's what you want to use. There is one more thing, and this is really cool. I didn't know this until a little while ago, but you can actually combine both of these. There is a YouTube video out there, and I have a link on it, and they actually have single SPA replace system.js, which is what it uses under the hood to manage all of these single SPA applications on the page. And they swap that out for module federation. So you get the best of both worlds. You can share resources and you can also like use different dev stacks. So if you're feeling really risky, I'd say try that out. But I'm just going to close with my little iframes and just talk about them just real quick. Coming back to where we started, I still believe, just because I see the success in them, that they are still a viable option in this landscape. They lack some of the bells and whistles like single SPA or module federation and being able to really create small bundle sizes. And on paper, that sounds bad for the iframe, but in actual real world like testing, I would say it's negligible or something that you should be mindful of, but there's ways to get your iframe bundles to be pretty small too. But the main drawback is each iframe has to just bring everything in to get it working. So that's not cool. And if I'm being honest, they do seem a bit dated compared to the newer approaches. Building your own messaging layer and accommodating iframes isn't easy either. So it's kind of like pick your poison, I guess, and see what you're comfortable with. There's pros and cons to each. I would say the main pro for module federation is the dynamic loading and good tree shaking. For single SPA, it's using whatever dev stack you want, all on the same page with great routing built in. And for iframes, I would say time to market, it's still something you might want to consider. It allows you to really get up and going with a module framework. And so the rationale behind our choice, again, I said timing. When we first designed the system, tools like single SPA and single SPA I don't think was even around, and Webpack Module Federation was just coming out. We were still on Webpack 4 at that time, and then Webpack 5 dropped, and with it came Webpack Module Federation, and it was still kind of just new. So they weren't really available or mature enough, we thought. We needed a fast way to integrate multiple pages into client sites. And then the last thing that you might want to consider, especially if you're like us, we are a very back-end heavy development shop. Team structure can influence the decisions. With back-end developers being so plentiful, we needed a way to kind of simplify things, and this allowed that. Iframes let us update modules independently without a deep front-end knowledge. So based on timing needs and team structure, iframes made the most sense for us. And that is part 2. And I can pause if we have any questions or whatnot. If not, we can go on to the last chapter. All right, so lessons learned. In this part, I think I will just talk about how to use the messaging layer to act as a glue for iframes. This is like the hardest part, I would say, of putting this together, and how to avoid over-engineering when it comes to, say, routing and navigation. And there's some other lessons learned along the way from our time in putting this together as a team. So communication really matters. In this example right here, for example, we have the Magic Coffee site. It's currently showing a coffee brewing wizard, and the site is the host site, and it's responsible for main navigation. and the wizard is an iframe that manages its own step-by-step process. So to reemphasize, the host site, without any custom messaging bus required, has the ability to load iframes that display various pages or modules, such as this wizard. When performing basic routing, the host site is only concerned with converting routes into various iframe URLs. Now, if a user navigates to the wizard, such as the Magic Coffee Brew wizard, then once the page is loaded, all users' actions related to the wizard are managed by the iframes module. However, what happens if the wizard wants to display an option? So if it wants to display an option to buy an item used in this brewing tutorial, so if a user clicks the buy button, things get a little bit more complicated. Iframes, as we said, they aren't very social. They prefer to keep to themselves. That's the great security they have, right? So to get our wizard's buy button to actually navigate to the shopping page's Hario V60 page, we need to provide a messaging layer that uses the Windows post message method so the two can play nicely with each other. It's a really simple API by itself, and you can use the Windows post message method directly, but I would really encourage you to either roll your own wrapper or piggyback off of another library out there that provides one. A good wrapper can add some extra utility and safety checks, and this is exactly what we did for our current approach. We leverage Window Post Message via a library called PostRobot to create a custom message bus. It intercepts deep navigation links like the one from the shopping and triggers things to the host site and vice versa. It can also broadcast user events. It has gotten us out of a lot of sticky, unforeseen, unplanned situations when product comes to us and it's like, we have this great idea. A lot of the time, our little messaging bus is like Thomas the Tank Engine just going up the hill for the win. So, or the little engine that could, if that analogy fits. So there is some gotchas though. I would say we have some iframe messaging gotchas. While the iframe messaging helps glue everything together, it's so important, I think, to plan ahead. We didn't do this enough. If you don't, you'll end up with, I guess, the thing that I would like to just captivate your mind with is a rushed arts and crafts project covered in Elmer's glue. Kind of like when I was in elementary, we were doing arts and crafts. It was either always Transformers or Ninja Turtles, but you could never tell what I was making because it was just a glue mess, right? So I kind of want to help you create a work of art. So might I suggest avoiding some of these mistakes we made? So no standards. You need to set standards. Our code quickly became spread out and hard to manage with this messaging bus. This made debugging hard and iterating on feature requests much more difficult. And this was because we were using the post-robot library in a fire and forget fashion in some areas. We sent messages out, but had no idea if the window receiving them was still around. And so this led to memory leaks. And let's talk about those memory leaks a little bit more. When we first started working with post-robot to create our message app, we didn't account for all the ways things could fail. And this is sad because post-robot provides what I call a robust handshake protocol. We used it, though, more like a quick high five because in some instances, not to anyone's fault, we just kind of assumed it would always work. This, however, caused an intense week of bug fixing after a major refactor with our host site. We discovered our navigation was loading pages slower and slower because the host site kept trying to send messages to clients that no longer existed. So to fix this problem, we made use of everything that post-robot offers for error handling. And so I guess that's what I want to emphasize is just assume everything will fail and test against that. And if you're interested in post-robot, you just have to Google post-robot and PayPal, and you should be able to find Daniel Bryan's really great article on him introducing it. Sad to say though, it was archived in January, and I don't know why, and I'm super bummed about that. So that's something to be aware of at this point. But it still works, and maybe someone will fork it at some near future point. So that is messaging. There is also some other hard lessons, and this will probably kind of just, we'll end with this, but hard lessons in micro front-end development. I would say we've already talked about invest early in your messaging bus. Very critical to think that one out, come up with some interfaces, protocols, or whatever to follow so it's testable and you're not finding yourself staying late up at night trying to debug memory leaks. It's not fun in JavaScript. So the next one is standardize. Despite having multiple repositories, come up with a way to standardize your navigation patterns. One area where we could have been more consistent is how we route drop-down navigation lists in drawers from settings to admin pages. We use them everywhere. And we use this kind of navigation in each app, but it's approached differently. And this makes it challenging to standardize how things are done when we have team members that kind of join other teams for a project. It's not always a one-to-one way of writing it, and it becomes a headache at times. And with that, I would say beware of over-engineering. To go back to the navigation drawers real quick, we kind of like tried to future-proof too many things. One example is in one app, we set up a dynamic routing to handle various payloads and display different navigation drawers. The code is impressive. There's nothing wrong with it. It works really well to this day. The only issue is that we only use it for a single list. So it was like designing a warehouse to store all of like Jay Leno's amazing like Hot Wheel cars, but you're just parking a sedan in there. So just be aware of over engineering at times. And I guess with that, accept that some wet code is okay. I don't know if you really should apply the drive principle so ruthlessly when you're making a module front end. Instead, I think there's something called RUG, which is like repeat until good. And I would just say, yeah, after over engineering ourselves into several corners a few times, we learned that a little bit of wet code is okay. And in a micro front end, I think some messiness is expected. Each team will do things a little differently. No matter how many guardrails you set up in place or how many like protocols you set up to say, hey, follow this pattern for this kind of thing, you're just going to have things diverge a little bit. And then the final one is, this is something that's not quite micro front end, but you should be aware of it because this one bit me in the butt too many times. The fallacy of staying current. This is something I had to learn the hard way. You don't always need to use the bleeding edge frameworks. Early in my career as an iOS developer, I was super hyped up every year because iOS was dropping 4, 5, 6, 7, and new things to learn, new things to do. I was hyper focused on avoiding like the static projects, and I pushed myself and sometimes the companies I worked for to update packages and libraries constantly. And no, there's an art to updating. After doing several big refactor projects, included in this micro front-end project that we work on, I've learned that sometimes it's better just to freeze it and create a new repo if business needs demand it. It's important to remember that while getting up-to-date libraries feels really good, it comes with a cost, and that is like, for example, if you are a back-end heavy development shop and you have just a couple of front-end developers that work with the back-end developers, training all the developers on how to work in the front-end stack if it's constantly changing is no good. So we want to be feature-driven and not just constantly be relearning how to make the same things. So it's not always ideal for a feature-driven development shop to be rewriting it all the time. So that is that. It took me a long time to learn that lesson, and so that's why I'm sharing it. But that is kind of the lessons that we learned. And with that, like this is probably one on the shorter side of one of these things. And I probably will say sorry about that. I took a real choice of not to share any kind of like live coding or anything because honestly, I think everyone's dev stack is so different in the front end, and it's not everyone's React. And so I think what I talked about tonight can be applied throughout any type of dev stack, whether it's vanilla JS or Svelte or Angular. So that is what we learned. And with that, questions and comments are always welcome.
Got a question. If you were gonna start over, like start today, do you think you'd still use the same approach or try to use single SPA, module federation, or a combination or something?
That is a great question, and I thought about it. And I think my current opinion is I would still use what we're doing today because it doesn't lock me into a third-party library. To be honest, I don't really like the direction like React is heading, and that's why one of the reasons why we're staying on 18. And so I think by having your own messaging bus and using something like iframes, it's the only thing that's stopping you is your own creativity on how to make things sync up.
I've got another question. If you're at maybe a really large organization where you don't have the governance to force or encourage what people are using, if you had like crazy fragmentation of like 5 different versions of Angular, 4 different versions of React, and everybody's using Lodash, you're importing Lodash n number of times. Is that correct? Is that like a downside then, if I understood it correctly?
That can be a downside if they're all like loading in those same packages.
Yeah.
Yeah, that is one reason why we actually jumped to the shared resource library, and we are in the middle of pulling out the last of our Lodash, and we just have a very lightweight safety library that we've kind of homegrown.
Gotcha. Okay, so if everybody can get together at least on the same version of Lodash, you put it in that shared resource library, and then you're not importing that n times.
Correct, yeah.
Thanks. And I've got a second question. I couldn't help but notice the vibrant graphics. Did you make those yourself?
Oh yeah, I purposely did them on like notepads, and you can see all the blue pencil lines because I wanted to make sure that like it's not mistaken for AI.
Gotcha.
It was pretty impressive.
That's awesome.
Thank you very much.
Neat. So yeah,
I
go
have a
for it.
question. Okay. So I am not a very capable front-end engineer.
Mhm.
My focus is back-end. So I'm making some assumptions that I want to validate. So I'm guessing when you said you're trying to restrict it to your UI to having one iframe, that the goal is that you have kind of your main page, which has one iframe, which is the main component that should be displayed on that. And then the message bus is what redirects, or I should say what directs the main page to choose from those things that should be displayed.
Yeah, I think I'm understanding. So like if we go back to this host site, the black box is the host site, and it loads locally like a main navigation and side navigation. And it also spins up at like its messaging bus. And how it kind of works is like if the iframes will go out there and they'll wait for like a handshake. And if they don't get that, then they kind of know that they're the parent. And if they, at that point, they'll take over and be the parent. That's the superpowers. But if they get a handshake right away from the host site, then they'll go ahead and authenticate with the host site, and they'll start relying on the message bus to kind of implement functionality. Like if a user clicks on the user profile and within there they click on like view my profile, well, to get that to navigate nicely over to like say our employee page down to that employee profile, we use the messaging bus to kind of like redirect and load in that nested that iframe instead. So does that kind of help?
Yeah, so In other words, you're not trying to say, hey, we want the side nav to be an iframe and whatever what you have on the right as the iframe module as an iframe and establishing communications between them. Rather, you allow your navigations, your main or your side navigation to control the iframe module, and then the iframe module just sends messages about what's happening via the message bus.
90% that is what we do. There is some times where like within an iframe, someone will click a modal. So like, for example, in the time card, we have it where they would click on like a geofence icon to see where the user clocked in at. And that loads a modal. And within that modal, we actually load in a geofence iframe. And so then you're getting multiple iframes playing around. And for the most part, that works seamlessly too, but you do have to be aware of some cleanup. So yeah.
Okay, so in theory, this would work if you wanted to do something that was more like some of the stereotypical micro front ends, where each component is independently, loads independently, and then you just send the messages between them. Okay,
yeah,
nice.
You could do that. It's just a lot simpler when you just do like a single page kind of layout.
Yes. Okay, thanks.
You bet.
Any other questions? I see some typing in the chat. Otherwise, we can wrap it up. Yeah, thanks a ton, Justin. Great presentation. Really appreciate it.